Let's continue with our study guide / practice test with problem number 6. So for problem number 6, in the diagram below, the triangle PQR is similar to right triangle PST. The question asks which pair of ratios is equal to the sine of angle P. So what I want to do with this one here, a good way to explain this problem is to take this triangle. We actually have one triangle and then it's embedded inside of a larger one. I'm going to actually pull those apart. So let's pull triangle PQR out. And what I mean by that is that I'm just going to rewrite it or redraw it here. So here is PQR. And now I'm going to go ahead and redraw triangle PST. So PST. And here's our right angle. All right, so now we can see that they are similar. One's larger than the other, right? Now, similar triangles are supposedly having the ratios equal to each other. So they have same ratios, not same side lengths, but same ratios. So let's take a look and see if that's true. So we're actually finding the sine of angle P. So we're looking from angle P on both of them, and we're looking for sine. Remember, sine is opposite over hypotenuse. So if I need the sine of angle P, then I'm looking for the opposite side from P. And in this smaller triangle, the side opposite P is RQ. So this side from R to Q, that segment, that piece. The hypotenuse, of course, the diagonal or the longest side is PQ. Since I didn't have any values there or any variables along the side, I just used the actual line segment. Now let's check on the larger triangle. Again, we're looking for sine of P. So here's angle P. I know that sine is opposite over hypotenuse. So the side that's opposite angle P on the larger triangle is segment TS. And the hypotenuse is PS. Now keep in mind with line segments, you actually can, if I wanted to rewrite RQ as QR, it's the same segment. It's not a different line segment at all, it's the same. So we can flip-flop those letters. So which pair is equal to sine of P? Well, I see that I've got RQ over PQ. So I'm looking for RQ over PQ. If you look here, here's, they've flipped it around, QR, which is the same, and PQ, so that's a possibility. But then it looks like all of them are that way. So we're looking over here. This is going to actually give us our answer. And we see that the sine of P for the larger one is TS. So I'm looking for TS. There's a TS. All of them have a TS, even though they flip-flopped it, that's okay. But then where's PS on the bottom? That's Q. There's no P here. Now there's PS, so that will fit. PT, nope. RT, no. So it has to be this one. Problem B, or choice B. Let's take a look at problem number 7. Problem number 7. In right triangle ABC, the hypotenuse AB measures 10 centimeters and the measure of angle B is 53 degrees. What is the length of AC, segment AC to the nearest centimeter? So we're asked to find this length right here, this leg. I'm gonna go ahead and give this a variable. Just make it X. So we're trying to find the value of X. So what we've got to do here is we're going to set up an equation using our trig ratios. But first of all, which trig ratio should I use? Should I use sine, cosine, or tangent? And we're going to find out by looking from the perspective of the angle that's given. So we're given angle B, and the only information that I see pertaining to this angle is I see some information opposite it, and I see the hypotenuse. So I see opposite over hypotenuse. And what that tells me is that this has to be the sine function. I'm gonna write sine of the angle. I don't have to put B because I have a degree measure for it. So I can go ahead and put 53 degrees. So I've just determined which of the three I need to use. Now let's go ahead and apply it. So this will be sine of the 53 degree angle is equal to the opposite information that I have is x. The hypotenuse that I'm given is 10. This is the equation we're going to use to solve this problem. So what we got to do is solve for x. Because remember, we're trying to find the value of x. So once I get that value, I'm done. How do I do this? Well, it's just an equation now. So with any equation, in order to isolate the variable, you use inverse operations. I'm going to start by getting the x by itself as much as possible. Now, if I want to get the x by itself on this side, since this is x divided by 10, the inverse of divided by is multiply. So I'm going to multiply by 10. Now keep in mind that when you're working with an equation, whatever you do to one side of the equal sign, you have to do to the other in order to keep the equation balanced. Since I multiplied by 10 on the right side, I've got to come over to the left-hand side and multiply by 10 also. Now let's see what we can do here. So these values are going to cancel each other out once we do the calculations. What I'm going to be left with is x, and that's what I wanted. I wanted x to be on one side by itself. But now I've got to actually do this work in order to get that value. So when we put this in the calculator, we'll put in 10 times the sine of 53 degrees. And it's going to give us 7.9. However, it says what's the length to the nearest centimeter. That means the nearest whole centimeter, because it didn't say nearest tenth or nearest hundredth. So we want the whole number value. If I round 7.9, it will give me 8 centimeters. Okay, there's the answer. Now let's take a look at number 8. All right, so here's number 8. Let's take a look at that one. We have a rope that's used to hold a tree upright. It is attached to the ground at a distance of 95 feet from the tree and forms an angle of 47 degrees with the ground. How many feet long is the rope to the nearest foot? Problem like this, now there's a test-taking strategy that we teach that's called draw a diagram. A problem like this, especially if you're a visual learner, you probably want to try to sketch a diagram of what the problem is asking you. So in this case, and I'm not the best artist, but I'm going to do my best. So just look at this, for example, it says we've got a tree, and we're told that a rope is holding the tree upright. So let's assume that the rope is coming here, holding that tree upright. So this is the rope, and that it is attached to the ground. So here's the ground. Let's just say that's, grass growing. Here's the ground. And so it's attached to the ground at a distance of 95 feet from the tree. So it's attached to the ground to the tree. So this distance is 95 feet from the tree. So this is a pretty decent facsimile of what they're asking us. It says also that it forms an angle of 47 degrees with the ground. So here's the rope with the ground. So here's the degree, and that's 47 degrees. So we need to find out how long is the rope. Let's just say that this is x. So we're asked to find x. We're given a side. So here, imagine that this is our right triangle. So we've got one side, we've got a degree measurement, and we need to find this value. So the first thing we need to do is take a look at that degree and figure out what information are we given, because we need to know which of the 3 trigonometric ratios we're using. Well, from this degree, I see if I look directly across, which is opposite, I don't have any opposite. But I do have a hypotenuse. You see the diagonal here? I've got a hypotenuse, and I have a side that's adjacent to this 47 degree angle. So what I have is I have an adjacent side, and I have a hypotenuse, okay? So this tells me that I have a cosine. Remember SOHCAHTOA? The C is cosine, A is adjacent, H is hypotenuse. So I've got cosine of this 47 degree angle, which is this ratio. Now, what is that adjacent side? It's 95. And what is the hypotenuse? It is the unknown, the rope. So here's the equation. Cosine 47 degrees is 95 over the hypotenuse. All right, So this is the equation we're gonna solve. Now we need to find out what the x value is. We're gonna solve for x. How do we do that? Well, you isolate the variable. In order to isolate it, we need to move it or get rid of whatever is there with it. Now in this case, since this says 95 divided by x, what we can do on that side is multiply by x. That's the inverse. So what I'm gonna do is multiply by x. But keep in mind, whatever you do on one side of an equal sign in an equation, you have to do to the other. So if I multiply by x over here, I've gotta do the same to the left-hand side. Multiply by x. So here we have cancellation. Now I've got x times the cosine of 47 degrees is equal to 95. So again, I need the variable isolated. I've got to get the x by itself. Now this says x times cosine of 47. What's the inverse of times? Division. And why am I dividing by cosine of 47? Because I want the x by itself, so move whatever's with it. And again, whatever you do to one side of the equal sign in an equation, you do to the other. So I have to do it over here too. Cosine 47 degrees. All right, these will cancel. My x will be left. And when we put 95 divided by the cosine of 47 in the calculator, we get 139. And remember, this is in feet. So the rope, this diagonal, this hypotenuse is 139 feet. Let's do number 9. So here's number 9. To the nearest tenth of a foot, how many feet tall is the tree illustrated in the diagram below? This is similar to the previous problem, except here they give us a diagram, so we don't have to try to draw our own. And notice that we have some information given to us. We need to know how tall the tree is. So there's your x value. If you notice, we've superimposed a right triangle over the tree. So we're looking for the x value. Now we're given some information that's gonna help us find it. We're given an angle measure of 62 degrees and we have a leg or a side of 15 feet. So what we gotta do is we got to take a look at that angle that we're given and determine whether it's sine, cosine, or tangent that's being used in this problem. So what information are we given? So from this 62 degree angle, I can see that directly across from it or opposite, that's where the unknown, the x, is located. So I see that I have opposite. And then from there, I have a side. So I don't have the hypotenuse. The diagonal is blank. Nothing we can do here. But I do have adjacent. So this looks like tangent, because tangent is the TOA part of SOHCAHTOA. Tangent is opposite over adjacent. So I'm gonna need to use this ratio. And that will be the tangent of this 62 degree angle. So let's fill out this information, the opposite and the adjacent. And then we'll solve for x to get our answer. Tangent of 62 degrees is equal to, the opposite is the x and the adjacent is 15. So we're gonna solve for x. That means we need to isolate the variable. In order to do that, I'm looking at x divided by 15. So the inverse of divided by 15 is multiplied by 15. Of course, whatever I do to one side of the equal sign, I have to do to the other. So I'm also going to multiply by 15 on this side. So here's our canceling. And now I need to calculate 15 times the tangent of 62 degrees. That's gonna give me the value for x. When I calculate that, I get 28.2 is equal to x. So there is, it says to the nearest, see, 10th. So here's the nearest 10th place, which is 28.2 feet. Now remember, in the calculator, we put in 15 times the tangent of 62, and that's how we get the answer. Okay, number 10. Let's take a look at number 10. In a rectangle, the length of the diagonal is 15 inches, and the length of the shorter side is 7 inches. What is the measure to the nearest degree of the angle formed by the diagonal, so this side, and the longer side of the rectangle? we're being asked for the measure of this angle. So what we got to figure out is, if we're looking for the measure of this angle, let's call that X. I'm just gonna call it X just to give it a point of reference. Now, in order to do that, first we need to identify what do we have. Remember, you always need to find out which trig ratio are you using, sine, cosine, or tangent. And in this case, from this angle's perspective that I'm looking for, it seems that I have a hypotenuse and I have an opposite side. This side directly in front of X is my opposite side. So if I've got opposite and hypotenuse, that's SOHCAHTOA, S-O-H, sine, opposite, hypotenuse. So that's the information I've been given. So that means I've got to use that. But keep in mind, we're trying to find an angle measure. So remember, when we're finding an angle measure, that's when we use the inverse function, remember? So I'm gonna use sine inverse. That's not sine to the -1 power, that's the symbol for sine inverse, or the inverse of sine. And then we still need to multiply that by the ratio. What's the ratio? It's the opposite side, because we've already determined this is sine over the hypotenuse. So let me write the ratio. So this will be the opposite over the hypotenuse. So what's gonna happen is, I'm gonna put that into the calculator, just like that. So I'll put in sine inverse. There is a button on your calculator that's sine inverse. And then I'll times that by, because sometimes, some calculators, you just put this push that button and then type this in immediately. And some you may have to put in the multiplication sign in between. So, we're gonna end up with 28 degrees. And the answer will be 28 degrees. Here's the degree symbol. And there's number 10, and that wraps up this portion of the video. So now I'm going to go ahead and let's look at number 11 through 15.